Good morning, everyone. Today, our topic is anatomical axis, visual axis, and angle kappa. And these three terminologies are the most important to learn the orthoptics. Now, first of all, we will discuss about the anatomical axis. As you can see, the posterior pole. The posterior pole is actually the point posterior to the eye, which is actually coinciding with the center of the cornea. So, the definition of the anatomical axis is this is an imaginary line which is moving from the posterior pole of the eye and passing from the center of the cornea and hit any of the fixation point. This imaginary line which is coming from the posterior pole of the eye and passing through the center of the cornea and hit any of the object of the fixation target, this imaginary line is called anatomical axis. And now we will discuss about the visual axis. Before learning about the visual axis, we have to learn about the anatomical position or location of the fovea centralis. So, if we have these two eyeballs, and exactly we have the nose, so the position of the fovea centralis is slightly temporal. The position of the fovea centralis is slightly temporal to the posterior pole of the eyeball. So this red line is posterior pole of the eyeball, right? And this is coinciding with center of the cornea. And the fovea centralis, this blue mark is called fovea centralis, and this fovea centralis is slightly temporal to the posterior pole of the eyeball, right? And in this eye, this is posterior pole of the eyeball, and yes, slightly temporal to the posterior pole of the eyeball, this point is called the fovea centralis. So in this aspect of the eyeball, this reddish area is called fovea centralis, and this is slightly temporal to the posterior pole of the eyeball. So the definition of the visual axis is when an imaginary line is coming from the fovea centralis and it is passing through the nodal point of the eyeball. The nodal point of the eyeball is the point where every light would go straight ahead, right? So this imaginary line which is coming out from the fovea centralis and passing through the nodal point of the eyeball, this imaginary line is called the visual axis. Now we will learn about the angle kappa. The angle kappa is the angle which is subtended between the anatomical axis and the visual axis. This angle is called the angle kappa. The angle which is subtended between the anatomical axis and the visual axis, and the angle kappa is always 5 degree. Now we will learn about the positive angle kappa and negative angle kappa. Now the angle kappa is positive when this fovea centralis is slightly temporal to the anatomical axis of the eyeball, right? I can write it for you. If fovea is temporal to the anatomical axis. So if the fovea centralis is temporal to the anatomical axis, this is called positive angle kappa, or this is also called the normal angle kappa, right? So normally the fovea centralis is always temporal to the anatomical axis. Now we will learn about the negative angle kappa. If under any condition this fovea centralis is somehow at the medial of the eyeball, at the nasal of the eyeball, this condition is called the negative angle kappa, right? If fovea is nasal to the anatomical axis, so this would be the negative angle kappa, right? So the normal angle kappa is 5 degree, and whenever under any condition if the angle kappa is larger than the normal, then we will get exotropia or exophoria in the concerned eye. Now we will prove that why we get exophoria or exotropia when we have larger angle kappa. As you know about the location of the fovea centralis, if this is the posterior pole of the eyeball as we have discussed, the fovea centralis is slightly temporal to the posterior pole, and the fovea centralis is the most sensitive part of the retina. This fovea centralis is most sensitive to the light, and whenever the light will penetrate in the eye, the fovea centralis will move towards the light, right? So this posterior side of the eye will move towards the nasal side, right? So this fovea centralis will move towards the light, towards this direction, right? And when posterior of the eyeball will move in the nasal side, then this anterior side, this corneal side will move towards the lateral side. So the cornea will move in the lateral side. So that's why we feel exotropia or exophoria.